Well, hello, everyone. You know why you're here. You clicked on the video. I'm Sean McElroy. This is our Autoline exclusives. And joining me today is Tony and Patrick from a company called Inmotive. I want to first thank you guys for taking the time to join me today.
Thank you for having us.
Thank you, Sean.
Yeah, so I know you guys have developed a two-speed transmission for EVs, and I'm curious, is this how you guys started out? Was automotive always in the outlook for you guys?
Yeah, I'll let Tony go ahead. Tony is our co-founder and the inventor of the technology. So Tony, how about you go ahead and tell Sean about our history?
Sure. Yeah. Automotive has always been our the target. It's the big kahuna, and we're also passionate about cars and electric vehicles. We really quickly identified that that was where we wanted to be. But back when we started in the early days, over 10 years ago, the industry wasn't nearly as active as it is now, and so we worked in industrial applications and whatnot, and developed the technology. But in the last few years, the EV industry has really grown, and all the OEMs are electrifying, and we're finding there's a lot of acceptance and need for two-speed transmissions. So we've always wanted to, but now seems to be the right time.
Yeah, and I gotta say, it's a very interesting design that you've come up with. It almost seems like there's some inspiration in there from pedal bikes with the derailleur system. It kind of has a similar look to it. Was there any influence there?
Absolutely, absolutely. I think when I was first conjuring transmissions, I was thinking about the shortcomings of the derailleur, and of course, it's not such a big problem on a bicycle. Shoving that chain side to side, it works, but there's actually several percentage points lost with regard to efficiency. So I was looking originally for a new way to make bicycles more efficient. I thought, well, instead of shoving the chain side to side, what if we move the cogs underneath? And what if to move them, we utilize that open space between the sprockets? And so what if we segmented these sprockets? But really, it wasn't until later that we realized that the real key to getting into high speed and high torque applications like automotive was our key segment. So it wasn't actually till a little bit later in the process of doing patent searching and whatnot that we realized we had something quite groundbreaking, if I may say myself.
And Patrick, can you give us a little bit of an idea? I know Tony kind of touched there about how this works a little bit. Can you go a little bit deeper into that for us?
Yeah, sure thing, Sean. As Tony just touched on, there's a bit of magic in the simplicity of our design. So as you can see, there's a video on our website and also on YouTube where it shows how the in-gear works. We move sprockets in and out as they rotate. But as Tony mentioned, there's a specific feature called the key segment. So not every segment is the same. And the key segments are the ones that guide the chain throughout the shift. So the magic is that the geometry, the shape of that key segment determines the smoothness of the shift. So we can change that shape, and because it's geometry based, it's repeatable every time. So you're not worrying about varying electronics throughout the shift. The behavior of our shift is exactly the same every time, and then we also use motor control. If you go back to the McLaren P1 supercar when it first came out, it was a hybrid, and so it had a mechanical transmission. And in the split seconds when they shifted, there's like a torque drop. They used the motor to infill that, so it had remarkable acceleration. We're doing the same thing with our motor on our demonstration vehicle. So we've really come really far, and really proud of the accomplishments of the team.
Is the gear ratio fixed then, or can you change that just based on what the automaker or OEM might want?
Exactly. It is fixed per the design. So we do pick a high ratio, a low ratio, but it can be customized either way. The technology is actually very flexible in that way that We can have different high-low ratios. We can have different overall ratios. We can work with a primary gear set. That's what we're doing right now. But it can be applied, right now we're using it in a demo car. It can be applied to go larger, to commercial applications, heavy trucks, 18-wheelers, as well as off-highway equipment, buses. We've actually got quite a bit of interest from the bus and commercial market because of the special feature that we have no loss of torque through the shift. That's something, if you imagine an 18-wheeler loaded going up a hill, a split second of a loss of torque, it can jar the vehicle. So there's a lot of interest there. We can also move smaller into ATVs, carts, even scooters. And then outside of automotive, we can even go back to the industrial sector as well. If you imagine this technology could be put into an air conditioner on the top of the roof of every building, reducing carbon emissions. That's kind of the view of automotive. But we do want to start at where we are right now. We've got a great proof of concept. We're driving it around, and we know that we have to develop it from there.
And the chain itself, I find the chain very interesting. It almost looks like a timing chain. Is it very similar in construction or the same as that?
Go ahead, Tony.
Oh yeah, absolutely. So there might be a slight difference from the timing chain, and that timing chains are often have a roller joint, but they're considered an inverted tooth chain. What we're using is silent chain with rocker joints. And these chains are extremely efficient, but they are used in automotive powertrain. So one notable application is the Chevy Volt. And in EV, well, with EV modes, and it really is a silent chain, but they're so efficient and so reliable that most people don't even know they have them in their cars. Most front-wheel drive and four-wheel drive cars have a chain pretty much just like this in their transfer case.
Oh, so that's very interesting. I mean, then it's got to be a very robust system or a very robust chain to begin with if it's already used in automotive applications. And that kind of stems into my next question, like, why not use a rubber belt or a gear set or something like an interlocking gear set? What are the advantages of the chain that drove you to use that?
Well, our principle of operation does require the use of some sort of endless member, as they call it in the patent world. So a tooth belt or a tooth chain are both possible. We've actually did a lot of development with tooth belts with carbon fiber cords. Really, really amazing devices, but nothing has the same torque density as these silent chains, and of course they are actually even quieter. They are extremely quiet, and they actually surpass helical gears with regard to efficiency. So that's why our move towards the silent chain has been a huge step forward in our development. It's what really makes us capable for automotive, and we're really impressed with these chains. And but it's also worth noting that our key segment, which controls the bend of the chain, is really carefully designed to maintain what they call in the chain business synchronicity, which is to say that we really have perfect engagement of the chain's teeth, even during a shift, even though we're engaging with two diameters of sprockets. We have an engagement of the teeth, which is a really excellent meshing. We impart forces on the chain that are normally seen during regular use.
Yeah, and I find it interesting that you've kind of developed a whole new two-speed transmission. There's already CVTs and dual clutches out there. Are you guys more efficient than them, and that's why you don't want to go with that sort of thing?
Yeah, well, I'd say that we don't usually talk about other technologies because we see ourselves as improving and moving towards, let's say, 2025, 2030. Where is the next level of transmission technology going? So CVTs are amazing, clutch transmissions are amazing, and they're being implemented right now. and they are really advancing where EVs are going. Our technology, when you look towards the future, you really have to have, as we say, three legs of the stool. And those are cost, performance, and smoothness. And we have all three of those. So, and the reason is it comes down to the simplicity of the design. We ultimately have a 3-post system with a chain drive and ball bearings, and there's nothing else really to the unit. Really, the magic comes in the shapes and geometry of those morphing sprockets, and that's really the magic of how we make this system work.
So that kind of leads me into another one of the questions that I have. You talk about there's not a whole lot of parts in there. We talked about this a little bit on our Autoline Daily program, and something I saw coming up in the comments is people are like, oh, EVs, they're all about reliability. They don't need a ton of maintenance. So they were saying, what really is the benefit? You might be throwing that balance off. How do you respond to someone that says something like that?
Oh, well, there's a couple of ways we can answer that. First of all, I actually love the fact that a lot of people are passionate about EVs. And, the first application is really the Porsche Taycan. And if you talk about that vehicle, there's really a strong split and a divide in the camps of 2 speeds are good and 2 speeds are bad, that kind of thing. That's not really for us to say. What we're saying is we see that if you move further and going into the future, there's always going to be a play for more efficiency. As we talk actually on this show, we talk a lot about, the Tesla's battery day, and then afterwards a redux show of there's things going on batteries all through the world. So if batteries all come down to equivalent prices, you're still going to be looking at efficiency. And a 2-speed unit allows a motor to work in its more efficient zone more of the time. That's just a fundamental principle. In terms of reliability, now if you go down, pushing the limits of efficiency, which we're doing, how can you do it in the most simplistic way? And we think we have that answer for the reasons we just said. A 3-post system, ball bearings, all the components that are used in our transmission are made today by existing suppliers. Our segments, we plan on doing it with the same supply base that's making sprockets today. Ball bearings, nothing new, and the rest of the processes are all known and globally available. So that's where the simplicity and reliability comes from.
And are there any sort of benefits? Tony, could you drive down like the size of a motor or something like that if you're using a 2-speed transmission? I think there's got to be other benefits down the line as well.
Absolutely, absolutely. When you add a second gear ratio, of course, you can get more performance out of a motor. There are some complexities around how much more torque you get in the constant power region, etc. But what we know is that if you want to downsize a motor and apply a lower gear ratio and spin that motor at really high RPM, it's still not operating optimally when it is up at 16,000 RPM. There's a lot of eddy current losses, magnetic flux losses, and you're still better off running motors like that at lower speeds, particularly if you design those motors so that they don't require high-speed operations. So we've been finding more and more that when we work with car makers and tier ones, their motor designers are quite receptive to bringing on board 2-speed technology because they actually understand that there are challenges to getting motors to spin at 16,000 RPM or faster.
So I know the modifier in me is going to want to ask this question. Is there any consideration towards an aftermarket solution? Can this be slapped into an existing EV, or is that not what you're going for?
Yeah, I'll take that, Sean. I'd say that's not what we're going for right now. But as I mentioned earlier, this technology is flexible to go into all sorts of different applications. So if the day came where we thought it was going to be a great business opportunity and even a great modifying opportunity to make up a unit that could go into a Tesla Model 3, giving it a different gear ratios for faster acceleration. Definitely you could do that.
And then in terms of like working with an OEM, are you trying to get in there early in on the design process so you can calibrate the transmission to a particular vehicle?
Oh, that's exactly the case. At this point, we're talking to, as Tony said, all sorts of different OEMs, different tier suppliers. We see ourselves as partnering with everybody, and we really do need to come in at the early stages. Just as you mentioned earlier, Sean, there's divided camps on 2 speeds versus single speeds and reliability and those types of things with EVs. At the OEM world, we hear the same thing. We're really at the beginning, the advent of EV adoption, and it's really starting to grow. So OEMs are wondering, what is the right technology? Which is the right one to go with? Our point is that we want to be there along with them. So even if they choose to go with a single speed, we're going to continue to develop our technology, and then we'll show them that it's here, ready, available to use when they're ready for it.
So here's the hard question for you. When will we see it in a vehicle?
Yeah, great question. As soon as possible, we hope. But my automotive background, what I tell to people all the time is we know where we are. So we've got a great proof of concept. I will tell you, and to all the viewers, we were told by technical experts what we've done, a certain part of it with our smoothness, they thought was impossible. And we actually did it. And they commented that we should congratulate our whole team. It's a great accomplishment. We continue to do that. So, but we know where we are. And we have a product development plan that spans a couple of years that includes typical automotive things that I'm sure you know and your viewers know: development, NVH, durability, reliability, testing. Words like validation, DVP&R, those are in front of us. But the point is, we know what they are. I've personally done them. People in our team are experts at doing them. So we know what the right things to do are. So, 2-3 years, I hope that's going to be in a car and you can drive it in the real world.
So Tony or Patrick, do you guys have any hard figures that we can give someone in terms of either performance increase or efficiency gains that you could see?
Yeah, I'll take that one first. Actually, Sean, we have it right on our website, our performance improvement values and our efficiency gain. I'll pick on that one for a second. That we've taken the efficiency map that we've measured internally, applied it into a mathematical model, and we're estimating that on a WLTP cycle, the typically worldwide accepted cycle, we're getting around 7 to 8% range improvement. And in fact, that entire simulation recipe, as we put it, is done through analysis software MATLAB. We have the whole thing actually on our website, and you can download it and run the same simulation for yourself. We don't have anything to hide, and in fact, a lot of the viewers will say, "Oh, how is that possible?" Well, you know what? If we got more motor maps, more maps of transmissions that people measure, you can download the recipe, run it through the same available software. MATLAB is widely available, and you can do the same thing yourself. It's only as good as the inputs. So really where we need to focus, especially on that, is what is the absolute best measurement of our transmission that we can get. And that's what really we're working on.
Yeah, no, I think you guys have got a very interesting product. Obviously, automakers are always going back and forth with one another. Right now, range seems one of the things that's really differentiating people from one another. And I've got to think that this is just another little piece that someone could add to their vehicle to say, hey, my EV is a little bit better than yours. So I imagine we will be seeing this in our products. So,
yeah, exactly. We feel the same way. On your show, there's been a lot of talk about the cost of an EV powertrain, and it's coming down, 50%, 60%. All of the latest news cycles, Tesla's Battery Day, GM's Ultium. But an EV powertrain is $10,000 to $11,000 approximately. I've heard on your show, and then your father typically says, the cost of a conventional ICE. If you talk to insiders, it's around $2,500 for a widespread 4-cylinder engine. Well, even if EV powertrains come down to $2,500. Today, automakers are spending on average $100 US for every percent improvement of efficiency they can get. And that would be at the lowest cost if batteries came down. There's always going to be a push for efficiency and performance, and we put it both together. And we really think we have a good package, so we're glad to hear it.
Yeah, I think that's a great way to wrap it up. Tony and Patrick from Inmotive, I really want to thank you guys for joining me today.
Thanks very much for having us. It's been a pleasure.
Thank you, Sean, and I look forward to continuing watching you and the Autoline team on a daily basis.
Thank you. Appreciate it.
Great. Thanks. Bye for now.
Thank you.